6.5 Parametric equations. We are taking the final on May 22nd and 24th. Okay, moving on. The purpose of parametric equations is that they show the position and direction of a projectile over a certain time. So that's what a parametric equation is for. The purpose of it is to show the position and direction of a projectile or something that's in motion. It doesn't have to be a projectile, but something in motion over a certain amount of time. Okay, time, which of course we use the letter T for, is called the parameter. Should we look up the word parameter in a dictionary? Do you guys know what parameter means? No. You don't want to look it up, or you don't know what it means? I was trying to see if I had the definition written down somewhere, because I know I've had my students look it up before. Anyone with an iPod and a dictionary want to look up parameter for me? Okay, while someone's looking that up, I hope, we're going to talk about what x and y tell us. X and y give the horizontal and vertical position of the projectile at any time t. Okay, parameter is kind of something that something else is based on, I think, is what I want to say. Did anyone look it up? Okay.
I think the ones that you're referring to is limits or boundaries or guidelines.
Sounds good. Guidelines, limits, boundaries, guidelines. So T is our guideline for figuring out where the projectile or the object in motion is going to be. All right. Let's do an example, shall we? So, because we're dealing with the horizontal position of an object and the vertical position of an object, and those are x and y, and the parameter that they're based on is t, generally when you're working with parametric equations, you have two at a time. They come in pairs, okay? So here's a pair of parametric equations. So x equals 3t minus 2. And y equals t plus 1. And we're going to go for a limited amount of time from 0 to 3. So here is an object in motion for 3 time units. And during those 3 time units, if we take any time during that time and plug it into these equations, that will give us the vertical and horizontal location of that object in motion at any of those times. Okay? So, these are 2 linear equations. We're not just going to graph this equation, and we're not just going to graph this equation, because we actually are going to graph it so that we just have x and y on the graph. The t value is actually not even on the graph. T is just a parameter. T is a guideline. T is not one of the coordinates. It's not one of the distances. It's not on the graph. It's kind of weird, but that's the way it is. So what we're going to do to graph this is we're going to start by making a table. And in our table, we want to have T and X and Y. Alright, usually they tell you what to use for T. So in this case, have they told us some numbers to use for T? Yeah, any numbers from 0 to 3. Do they have to be whole numbers? No, they could be decimals or fractions because it doesn't say, right? So they could be in between. But definitely the whole numbers would be the easiest ones to work with, and then we can just connect them, right? So I'm going to go ahead and put down our whole numbers from 0 to 3. Then what we do is we take each one of these time values and plug it into each of these equations one at a time and get the x and the y values for each time. So, time equals 0. Jordan, help me out. Find x for me. What are we going to do? With t equals 0, how do we find x? 3 times 0 minus 2. Okay, Candace, do the next one. Should we do all the x's first and then all the y's, or should we do x, y, x, y, x, y? How do you want to do it? All the x's. Okay, that way we'll stick with one equation and do all the x's and then do the other equation. So Candace, find the next one. 3 times t is 3 minus 2 is 1. Good job. Bryce? So 2 times 3 is 6 minus 2 is 4. Good. Let's see. Kyle?
9 or 7.
Good. 3 times 3 is 9 minus 2 is 7. Good. So there's the x values. Now we take the exact same values of t and plug them in to find the y values. So Cody, for t equals 0, what is y?
1.
Good. Sierra, for t equals 1, what is y? Perfect. Morgan, for t equals 2, what is y? Good. And Kamai, for t equals 3, y is 4. Okay. So t was just the parameter, just the guideline that we plugged in to help us find these positions of our object in motion, right? So guess what we do now? We ignore the t. And we graph these points. So we're going to graph -2, 1, 1, 2, etc. from our x and y values. Does that make sense? Okay, so x is -2, +1. So is that where the graph starts? Since that's time equals 0, isn't that where the object starts moving? So that's kind of an important point to realize that's your starting point. Okay? Then we go to 1, 2. Then we go to 4, 3. Then we go to 7. I probably should have used graph paper because I think I've graphed unevenly. 4. Now the object stops moving after time 3. So is that our ending point where the object stops moving? Okay, so this graph is showing us the path of the moving object. The moving object starts here and is moving toward there. So usually we even will put arrows in the graph to indicate what direction that object is moving. Putting the arrows in there like that is called the orientation of the graph. So if a problem asks you to show the orientation, it would be by putting arrows in. So I'll just put a note of that. Orientation, which is direction, shown by arrows. So t was just a parameter, just a guideline. Okay, let's practice doing this one on a calculator. So in our calculators, we have a mode. So go to your mode button if you're following along. Right now my mode is in polar, but I want to change it to parametric, which is that one right there, P-A-R. So we go to mode, par, whatever, parametric. Okay, get out of the mode. Then go to y equals. What do you notice? Instead of just having y equals stuff, and you type the stuff in, it's x and y. And the little t indicates that it's a function of t, sort of, or t is the parameter, t is the number we plug in, sort of idea. Okay, so we're going to take x and plug in our x equation that we just did. 3t. Oh, it's not an x, it's a t. Amazing. And then y, we're going to do t plus 1. Okay, now before you graph anything, you need to go to window. What's our t minimum value? 0. What's our t maximum? 3. From our graph, oh, t step, that means how often it puts a point. So you could do like 0.5, whatever you want to do. X minimum, we just need to make sure our x and y's will fit the graph we're trying to graph. So we need to make sure that x goes to -2 and +7. So would it be okay if I just went from -10 to 10 instead? Doesn't matter. Or you could go from 2 to 7. It doesn't matter. -2 to 7. And then how high does our y value need to go? The y value smallest is 1, highest is 4. So 0 to 5 would be enough. I'm going to go -5 to 5 though. Oh, x scale. Sorry. X scale, I'm just going to count by ones. So y I'm going to do -5 to 5. So I'm T-step, you can do 1. I did 0.5. What that means is it'll put a point every 0.5 for T. Like it'll, so you know how we did 4 points because we did 0, 1, 2, and 3? That means your calculator will do 0, 0.5, 1, 1.5, 2, 2.5, and then 3. So that's how often the calculator will calculate the values to graph it for you. Okay, so now I'm going to hit graph. Oh, and I forgot to change it to a connected. I noticed when we were in there that my graph was going to make it a dotted one. You can just go over there and change it so it's connected instead. There it is. And if you actually watch it graph, I don't know if you guys watched it. Here, I'm going to turn this off for a second just so my graph clears. Oh, it didn't work. Okay, turn that one off. Okay, they're turned off. Okay, so now I have a blank screen. Okay, sorry, I'm showing you what I'm doing. I just wanted you to actually watch it graph, because remember, this graph is showing us the motion of an object. So when you first type them in and you hit the graph, you're actually like, in fact, it might be easier if you changed this to what I like to call the football graph. You know what I'm talking about? It's like you actually have the object moving, because it puts a little circle at the end of it. Let's do that one. So then if I hit graph, I can actually watch where the object moves to and from. I mean, from there to there. Did you see that? So that is showing the motion of an object from time 0 to 3. The football graph? On the TA83, you can just arrow over to the side of the whatever you're graphing, and you can change it to a dotted line, a solid line, or there's this one that has like a little circle at the end of it. Yeah, kind of cool. Okay, so we know how to use the calculator to check our answers. Let's do another type of problem.